Today, we're going to talk about proportions. Proportions. And let me move this over. Okay. So, uh, proportions. So, proportions are a method of relating one quantity to another. And how we do that, how we usually do that, we write a proportion as a fraction. So if you guys did the survey I posted yesterday, like the reason I was focused on the fractions and ratios and stuff is because I want to talk about proportion, and they're really heavily related. And wait, let me just check something. Oh, good. Okay. Yeah. So an example would be, so let's say I have 5 apples, and then they cost 80 cents. No, 40 cents. 40 cents. 80 cents would be too much. So here we create a relationship between apples and cents. So apples and cents. So we can essentially say that 5 apples is equal to 40 cents, right? So 5 apples cost 40 cents. That's essentially saying that the relationship between apples and cents is that 5 apples equal 40 cents. So then, to write this as a proportion, we can do, so we can write it either way. Apples apples over cents, so money in this, what cents represent is money, is equal to 5 over 40. Or we can say that cents over apples is equal to 40 over 5. Now you see that these two are different fractions, right? But that doesn't actually matter, because what we're just trying to create a proportion between apples and cents. So if you put apples on top, then the numerical value that apples represent will go on top, and cents will just be down. And if you want to write cents first, then the cents on top and apples on the bottom. So 5 over 40 and 40 over 5, yes, they're different values, but they also kind of represent different things. Like usually how you would see this, right? Like usually in the supermarket, you won't see like 40 cents for 5 apples. Usually what you see might be uh so for this one, 40 cents over 5 apples. I can reduce this. So I'll just do it here. I like if I divide this by 5 and I divide this by 5. What I get is 8 over 1, right? So 8 cents per 1 apple. And like in the supermarket, that is also what you're going to see. So like you're going to see something like 8 cents per apple. So this is like essentially these prices, they are a proportion. A relationship between how much money something costs. So 8 cents per 1 apple. That's what a proportion is. So this example here, wait, yeah. So this example over here represents something called uh, direct proportion. So this is a really important word over here. I hope you guys remember it. Like you'll see this in math contests, or just as you go higher into school, like higher grades, you'll come across this very often as well. Like in high school, even in like grade 8 maybe, you will see this direct proportion. So direct proportion. Let's talk about what the characteristics and some of the properties. So first, what here? No, black. So direct proportion, right? So so for direct proportion, no, maybe like this. Yeah. For the quotient. So does anyone know what a quotient mean? Hello? Does anyone know what a quotient mean? No answer. You can type it into the chat as well. So if you look at the text channel, there's a class C text channel, and you can also write down what you think or like what questions you have into that chat. Okay. Anyway, yeah. So the quotient is essentially when you divide a number, you get like the value here. This is called a quotient. So when something divides, yeah. So the quotient of a direct proportion is always the same. So what does this mean? Oh, and like in math, when something is the same, we call it constant. Yeah. So when something is the same, we call it a constant. So this means that when you look at the apple example, one apple is always going to cost 8 cents. And 8 cents is always going to buy you one apple. So when you increase the number of apples, each apple is still 8 cents. So when you increase the number of apples to 5, then you would need to have 40 cents to buy that 5 apples. And when you simplify it, it comes down to 8 cents per apple again. So the quotient, so 40 divided by 5 is equal to 8, and then 8 divided by 1 is equal to 8. No, 1 apple in case. And then, so say if I have like 3 apples, then I'm gonna need 24 cents. So why? Well, if 1 apple is 8 cents, then 3 apples I just simply multiply by 3. So then I get 8 times 3 is 24 cents. And when you divide 24 by 3, you're going to get 8 cents per apple again. So the quotient of a direct proportion is always the same. So always constant. That's the And then, as I was kind of saying just a moment ago, that when you increase one quantity, the other increases as well. And similarly, when you decrease one quantity, other decreases as well. Now this might seem like pretty straightforward, pretty simple, but the reason why I want to uh, especially note this is because when we look at like another type of proportion, so that would be called inverse proportion. We'll probably talk about that another day. It is not the same. So for inverse proportion, like when you increase one quantity, the other actually decreases. So there's actually a difference there. So for direct proportion, I want you to remember that when you increase one quantity, the other increases as well, and when you decrease one quantity, the other decreases as well. And I think that is pretty like obvious how like when you like increase more apples, you need more money to buy it. And when you want less apple, you don't need as much money. Okay, so does anyone have any question for what I am just talk about right now? For what I have just talked about right now? If you have no, just say no as well, please. Kind of quiet. You guys are kind of quiet. Oh, no, okay. Oh yeah, no, but sorry, I just saw it, sorry. Yeah, okay, good. Okay, and James, following along? Yeah, so James, you can type in the class C chat if you want. Okay, good. Yeah, no questions. That's good. Yeah, pretty simple for now. So let's get back to it. Well, I'll give you some really basic example for now. So like according to this proportion, right? 8 cents per apple. How how much does 8 apples cost? And you can just type it into the chat or say it out loud. How much does 8 apple cost? Yep, 64 cents. Good job. Now, this is really simple, but I want you to take note of how I do it, okay? So because like this is a pretty nice number, 8 cents per apple, per one apple. That's pretty straightforward. But in the later example, it won't be that nice of a number. So I want you to notice how I do it, okay? So I'm going to let the cost be X. Yeah, so we're doing variables here. So that is why I asked if you guys know how to do variables. So let the cost be X. And so by proportion, what do we have? Well, the cost, so cent, oh, go back to cents over apple. This is equal to, so first we look at our direct proportion, right? Our direct proportion say is 8 to 1. So 8 over 1, that's our proportion. 8 over 1. And then, so that is equal to, now we want to find out how much 8 apples cost. So we need to find out the relationship between 8 apples and the cost X. So the cost X will be on top. So that's cents, how much the cost. And then over apples. So we have 8 apples. We want to find the cost when there are 8 apples. Now, so by like just looking at it, you can already see that this is 64. But the way to do this, like when it gets really complicating, what we do when we have like this sort of equation is to multiply, is to cross multiply. That's is what we like to call it, cross multiply. So essentially, you multiply these two things, each of these two. So what you will have is 1 times, oh yes, when I do a multiplication, I'll draw like parentheses. 1 times x. So you multiply this on one side of the equation, and that is equal to 8 times 8. Now there was a question on the assessment, right? Where it was something like this. Like I forgot the exact question, but like there was like something here over something, and then you have to solve it. Some of you guys didn't get it because you guys probably haven't learned how to solve it, but now I'm telling you, this is how you do it. You cross multiply. So the top multiplied on one side multiplied by the bottom of the other side, and then the bottom of one side multiplied by the top of the other side. That is how you do it. And now 1 times x is simply, so x is simply equal to 64. Oh, maybe I'll just back. 8 times 8 is 64. And yeah, that's the answer, 64 cents. Okay, so yeah, cross multiply. And then another example then. So this one, so now if 5 apples cost 39 cents, how how much does 3 apples cost? And this is what I'm talking about when you need to set up the equation here, because it's a little bit more complicated. So how much does 3 apples cost? And again, you can type it into the chat, or you can say it out loud. So again, if you remember proportion, so I first wrote the what over what, and then the relevant proportion, and then what, and then we let the x be something. And proportion doesn't necessarily have to be like cents over 1 apple. Like anything is a proportion. Like 39 cents over 5 is a proportion. 39 cents over 5 apples. That is the proportion. You can simplify it, but there will be no need to simplify it actually. So what's the answer? Or if you're stuck, please ask question in chat or in voice. Nobel, what do you think? How about Chloe? Oh, oh, I see something. You have no idea? Okay, it's okay. I'll talk about it. Emma, were you going to type something? No. Okay, yeah, that's okay. Oh, we're here to learn. So what you would do? Now, so I'm going to write it out again. the proportion. So apples over, if you can see over here, it actually doesn't matter if I put apples on top or cents on the bottom, because either way, when we cross multiply, the things are going to group together on one side, and on either side, it doesn't matter what side the product is. Like 8 times 8 could be on this side, and then 1 times x could be on the other side, and that doesn't change anything. Is there any more on? No? Okay. So so this time I'm going to do apples on top. So apples over cents is equal to 5 over 39, right? Because when I have 5 apples, this is equal to 39 cents. 5 apples is equal to 39 cents. So as a proportion, we write it as 5 over 39. Now the reason why we want to write it as a proportion is because it is a direct proportion. And for direct proportion, what's the characteristics? The quotient of a direct proportion is always the same. It's always constant. So this means we can figure out how, like with 3 apples, we can figure out the cost. So, oh wait, I forgot to let x. My bad. My bad. Just going to move this down here. So let x be the cost of 3 apples. Now, apples over cents is 5 over 39, right? So we know that we have 3 apples. So this time we want to figure out 3 apples. But we don't know the cost. So I'm going to say it is x as indicated here. So why is this an equal sign here? Because the quotient of a direct proportion is always the same. So 5 over 39, this gives a quotient, and that is going to be the same as 3 over x. The quotient is always the same. Apples over cents, whatever this gives, is always the same. And that is why we can set up an equal sign over here. Equal sign means the same. So now I'm going to solve it. How? Well, just like how I talked about cross multiplication. So I will have 5x, 5 times x is equal to 39 times 3. So cross multiplication. This times this is equal to this times this. Now we have 5x is equal to, oh, I forgot what this is. Oh, 117. 117. So now we want to find the cost, right? X is the cost. So we will divide both sides by 5 to isolate x. And I think you guys all know how to solve this. So you can leave it as 117 over 5, or this is a pretty nice number. X is equal to 23.4, and our unit is cents, 23.4 cents. So how much does 3 apples cost? 23.4 cents. Okay. So any questions on this example? No, no question. Oh, do you mean? Oh, okay. You were typing something, Nobel? So no questions or yes questions? So I set this up. The proportion is always the same. And given this proportion, so this is the proportion that we have. And then this is one of the quantity we have. Or maybe I'll write this down to make it more straightforward. So, mm, so given a direct proportion, and we'll talk about inverse proportion in a later day. Given a direct proportion between two quantities, uh, and the value of one quantity we can figure out the value of the other quantity. Okay, so some things to highlight. You need a direct proportion first. So, uh, so in this question over here, the direct proportion is the 5 apples and the 39 cents. That is the direct proportion that we are given. And then given the value of one quantity, so the value of one quantity, and in our previous example, the value of that one quantity is the 3 apples. And with that, we can figure out the value of the other quantity. So the value of the other quantity in our and again in this example is the cost. So this cost over here, x. So given a direct proportion, 5 over 39 between two quantities, so apples and cents. And the value of one quantity, we only need one, so the 3 apples. We can figure out the value of the other quantity. So, and then, yeah, we figured that out, 23.4 cents. That is the cost. So how about let me give you another example then. Yeah. Slightly different this time. So not apples and cost. So a, a pole. Oh, no, no. A 10-foot pole casts a shadow of 7 feet. How long of a shadow plus, let's say 13-foot pole cast. So this is the, so maybe a suggestion to where to begin is to kind of draw it out, like, or if you can kind of imagine what a pole and a shadow does, right? So a pole, if it's high enough, the sun, when it shines on it, casts a shadow. So yeah. So go ahead and try it out. And remember this method. First, find the direct proportion, and then look for the value of one quantity, and then figure out the value of the other quantity. Okay, maybe 3 minutes. And if you have any questions, you can please feel free to ask. And when you're done, just type your answer into the channel, the chat. Oh, do we have an answer? 17.2 feet? I don't think so. 9.1? So Emma, um, like if we talk about direct proportion, what you will find is that the 10-foot pole casts a shadow that is like 7 feet, and that's like a bit shorter, right? So for a 13-foot pole, it shouldn't cast a shadow that is longer than 13 foot, if that makes sense. Because the like when this increases, the pole, like when the pole, the height increases, yes, the shadow length also increases, but then it won't exceed the length of the pole. Yeah. 10/7, okay. 9.1. So we're getting to 9. Well, okay, so Emma, so you put 10 over 7, and then what did you do after that? X on 13. So let's see. So 10 over 7 and X on 13. Oh, I see. So, okay. Well, so I'm gonna say that so for Chloe and Nobel, 9.1 is the correct answer. And Emma, I think you just kind of gotten a little bit mixed up, but that's okay. So you did this, right, Emma? So you did 10 over 7 is equal to X over 13. Well, yeah, and then yeah, that will give you around 17.2. Yeah. But the problem here is that if I write it out, right? So 10 over 7 is okay, totally fine. So that will be pole over shadow. So pole over shadow, yes, it is indeed 10 over 7. But then when you let it as x over 13, what happens? Well, x is supposed to be, this is supposed to indicate shadow. But now you put it at the top where the pole is, and 13 is the pole. So these two, you have to switch it around actually. Do you see what I mean? Like pole is on top and shadow is on the bottom. That is the proportion that is the proportion you're starting off with. So you're starting off with pole to shadow. So 10 over 7. But then when you set up the other side of the equation, you let it be shadow over pole. So remember how previously I was saying that they are a bit different. Like 5 over 40, like apples over cents equal 5 over 40 is a little bit different from cents over apple equals 40 over 5. They are a bit different. So that's why you have to keep consistent. So if you put pole on top, you left 13 on top. Oh, yeah, okay, yeah. So yeah, so that's the thing, right? Like when like I'm talking, like the thing I don't quite like about chat is like when I'm talking, but like you already got it. Like I don't know because I won't see it that quick. So like after I finish explaining, then I like see the chat. But yeah, that's okay. So yeah, and 9.1 is the correct answer. Good job, guys. Um, so yeah. So let me just quickly do it again in case you guys want to see. So let X be a length of shadow. And then I'm going to do pole over shadow, okay? So just 10 over 7. So this proportion is equal to 10 over 7. And then on the other side, we have 13 over x. And again, we do cross multiply. So 10 times x and 7 times 13. 10x is equal to 7 times 13 is, I forgot again. Oh, 91, yeah, 91. And then x divided by 10 is equal to 9.1. And yeah, feet. Okay, good job. How about just one more example, just to confirm that. So, oh, Michael Jordan. You guys know who Michael Jordan is? He's a basketball player from considered one of the greatest basketball player of all time. Uh, scored 124 points in 4 games. Yeah, in 4 games. At this rate, how many points will he score? When he finishes 10 games. And this 10 games also include the 4 games he already played. So, yeah. So the 10 games also include. So the answer will also include the 24 points he already scored. So that is the question, and I will give you guys some time to do it. There are actually 2 ways of doing this, and I'll show both ways, but you guys can try it out right now. Okay. $310. Okay. How about other people? Any different answers? I'm not saying that 310 is wrong, but just, and I'm not saying it's right either. Still pending. Oh, by the way, this class ends at 11, so we have around half an hour left. Okay. How about Emma and James? James, any ideas? You guess. Okay. I didn't say they were right. Try it out yourself. Uh, how about you, Emma? Are you a little bit stuck or just taking time? It's okay. Give you a bit more time. Oh, good. Yeah, good. Okay, yeah. Yeah, good job, guys. So, yes, 310 is the correct answer. Oh, you know something. 10 equals. Yeah, yeah, that's how you can do it. Yeah. Oh, Chloe, you're typing something. Uh, let's see what Chloe types first. So 124 times 10. Oh yeah, yeah, just about the same. Yep. So good, good job. Oh, is there something else? Oh, wow. How did you get the color? Nice. Yeah. So I, I guess I would do it in different ways actually. So the first way is I think how um you did it. Many of you did it was you put the points over games, and that is equal to 124 over 4. And then you must have let the x be the number of points he uh, scored in 10 games, right? Hey, yeah. So then you cross multiplied. Well, I guess for Nobel, he just divided this out first. Oh, also good. Yeah, it's essentially the same thing. So 124 times 10 and then equal to 4x. So 4x and then x is equal to 310. Yeah, so 310 points. Now, the other way to do it actually is that instead of figuring out how many points he scored in 10 games, we know that he already finished 4 games. So that means he has 6 more games to go, right? And then for that 6th game, since he scored at the same rate, that means the proportion will still be 124 divided by 4. But the number of points, I'll call it y now. So points scored in 6 games. And that is over 6. So that will be 124 times 6 equals to 4y. And 124 times 6 is 744 is equal to 4y. And then y will be equal to 186. I think, right? Wait, no. Yeah, yeah, 186. And then at the end, uh, just, so that's only 6 games. So we will have to add 124 plus 186, and we will get 310 points. Now, yes, the second method is more work. One more steps, oh, one more step worth of work. And then you also have to consider adding them together, and you could have missed that. But then this just shows that there are like different ways to do a question. And then sometimes, yeah, more, well, for this question, this way is the first method is of course the simpler one. But you know, sometimes by taking the extra steps, you could actually simplify stuff a lot. Like I can't say anything about this question, but like maybe I'll give you a homework question. where it would actually be simpler if you like try doing something other than a straightforward method. Why? Well, sometimes maybe the numbers, like if you do them like in one step or something, it will be like very nasty numbers, like decimals and like a really weird fraction. But whereas if you try to do a little bit of extra steps, the numbers might be a bit easier, like a bit nicer to look at. So you just want to find the method that's most suitable for the question. So, oh, oh, that's nice. Yeah, yeah, it looks pretty nice, Nobel. How you write out the write out your numbers, the multiplication. Okay, so I think everyone is getting this, which is really nice. So direct proportion. So we have half an hour left. Maybe let's see. Hmm. Well, I guess we can move on to the other topic then. The No, not the inverse direction proportion, but something called ratios. It's just really similar. And I know that uh Chloe and Chloe and Nobel who answered and oh was there someone else? I think so, but I think it was James who said they know about ratios as well. And that's good. But essentially, and ratios is just another way of expressing proportions. They're really, really similar. Or as you can say that they are the same essentially, but just another way to say it. And so how we write ratio, I think you guys know is uh so let's say apples to cents. So apples, we put this dot colon. This is a colon to cents. We can say that it is 5 to 39. So that is essentially what we're saying, how 5 over 39. And yes, this can also be treated as a fraction. So, and then how we say it is apples to cents. So this is the 2. That is the colon. And then 5 to 39. Yeah. So like you don't see ratios as often is because like just doing the math is like not so doesn't look so nice because like when you write it as 5 over 39, right? Like you can just manipulate this as a fraction, but when you see a ratio, you have to like change it. You have to first change it into like a fraction, and then you start manipulating it. So that's like one extra step. That's why people don't quite use ratios as often, but you will still see them in like contest questions or like I think like in middle school. I learned it in middle school as well, like just here, like ratios. So yeah, so you do see people writing it, and I guess one other thing. Oh, so yeah, what's the nice thing about ratio is that the oh, can be ratios of multiple quantities. And by multiple, I mean more than 2. So yeah, so that's the nice thing about it. So you can have say uh, apples to maybe grapes to banana. So you can have three or even more. Yeah, let's put one more. To let's say oranges is equal to, oh, I can't really do it. So I'll put it at the bottom. Equal to 2 to 5 to, I'm just making numbers up. So, well, yeah, it's just to like show you that it can be different. So 5 to 3 to 7, let's say. Yeah. Now, so you cannot put this as a fraction. Like, cannot. So never do this, okay? So 2 over 5 over 3 over 7. That is totally wrong. You cannot do this. So you cannot put it as a fraction. I'm going to highlight this. Never, never do that. Okay. Like if you do this, oh God, you're in big trouble. But what you can do is you can do apples, like what this benefits is by like you can do apples over oranges. Now you can do that. And what is that equal to? Well, that's just equal to 2 over 7 or like 2 to 7. So apples to oranges. Or you can do apples to grapes. And apples to grapes is equal to 2 to 5. 2 to 5. Or 2 over 5. Whatever method you like to write it as. And so that is the benefit. Like by comparing all these quantities, like you can pick two out. Remember, you can only pick two out and write them as a proportion. And sometimes that can be useful. So I'm going to erase this for now. And I'm just going to never put as fraction. But you can pick two out of the total quantities and as a proportion. So when you pick two of them, you can write it as a fraction. Okay. Now, so that's just kind of the brief introduction. So it is just another way of expressing proportions. And one common type of question involving proportion. Oh, I mean ratios. One common ratio problem, one common type of ratio problem involves boys and girls in the class. So example. Hmm, the ratio of boys to girls in a class of 35 students is 3 to 2. So how many girls are there? Yep. So that is the question. So like when like usually this type of question, they just change the ratios, change the total number of students, but everything else is like how you would do it is the same. So like once I tell you, or once you figure out how to do it one way, you can do like any number of students on any with any ratio. So try this out. Maybe 5 minutes, 7 minutes if you need. 14 girls and oh, that's quick. Well, how did you do it, Chloe? Did you just try out numbers or did you like use a method? Ah, so okay, so you tried 7, I see. Mm-hmm. Yeah, so like trying numbers is a good strategy to start actually. And this for this question is actually an easy strategy because the numbers are small. But what if I tell you now like the ratio is 147 to 281. And in total, there are 2,521 students in the class. Huge numbers, I know, but how about then? How will you solve the question? So I like how you got a 7. Yeah, that's a you try like multiples of 7. Nice. So maybe you want to go on to explore like maybe the relationship. Like why is there a 7 over there? Okay. That's a good way to look at it. Trying out numbers that can divide by 35. Yes, because people are always whole numbers, so you must have whole numbers. Good. Yeah. Yes, that is a good idea. But again, like it only works for small numbers. So for like bigger numbers, it doesn't work so well anymore. Yeah. How about Emma? I saw that you were typing something as well, but then you faded off. Were you going to say something? Oh, okay. Yeah, yeah, that's okay. Yeah. So, yeah, Nobel and Chloe, yes, it is a good idea to to try things out. Like when you do a problem, like you don't quite get how to start, well, you can just start trying things out. And if it just happens to be this problem with small numbers and nice ratios, then you just got it. It's easy. Um, so now how you got that seven? Well, I'm going to tell you how you're going to get that seven. So when we look at ratios, like to do this type of problems, sometimes people like to put ratios to draw it out. Like, so let's say that this box here, this box represents total number of students. Okay, so this box represents total number of students, and in this case, this would be 35. But I'm not too worried about this right now. Now, the ratio is 2 to 3. So that means for every 3 boxes, right? No, not that. Maybe here. So for every 3 boxes, we'll color this blue. So for every 3 boxes, so that is for boys. The blue box is for boys. There will be 2 red boxes. Does that make sense? So blue box represents number of boys, and then red box represents number of girls. So for because for every 3 boys there are 2 girls. So for every 3 boxes of boys, there are 2 boxes of girls. Yeah, so actually you can even kind of imagine this maybe as a classroom. And then in the classroom there are 5 different sections. So for 3 sections of boys containing boys, there are 2 sections of girls. And in each of these sections, each of these boxes, the number of people is the same. Now, so for 3 boxes of boys, there are 2 boxes of girls. So in total, you see 5 boxes of people, right? So you see 5 boxes of people. 1, 2, 3, 4, 5. 3 plus 2 is 5. Now, so this is where you get the 7. So first, I'm going to find out how many people are in each box. So how do I do that? Well, each box has the same number of people. So in each box, you have 35 divided by 5 is equal to 7 people, right? So that is where the 7 comes from. So you try out numbers and you got a 7. And this is what the 7 represents. It represents that when you, like, if you do it like this, like as a box, then in each box there will be 7 people. Now, girls make up 2 boxes. Girls make up 2 boxes. So in each box there are 7 people, so 7 times 2 equal to 14. 14 girls. And it's just like that. 17 girls. Okay. So any questions on that? I did go pretty fast, so if you if it's still a bit confusing, let me know. Or nope, as in no question or you don't know what it is. No questions, right? Okay, good. How about other people? Chloe, Emma, James? Good. Yeah, so this is a method you could try when you see these kind of questions. Now there is another method that is doesn't involve drawing. It's purely algebra. So so this is method one, and now I'm going to do method two. Method two, well, I won't. Yeah, it's about the same. Like you can use this method for other other questions as well. But yeah, like you can use this the box method for other questions as well. But you can also try this, like see which one you prefer. So again, I'm gonna write out the condition that for every 3 boys there are 2 girls, right? Well, this condition, like if you don't draw the boxes, it's actually not that useful because we don't know how many boys there are and we don't know how many girls there are. Well, that's what we're trying to figure out. We only know the total. But now let's imagine. First, we imagine. So that there are only 5 people in the class. Not 35, but only 5 people in the class. So in that case, 2 out of 5 of the 5 people are girls, right? If there are 5 people, then 2 of them are girls. Now notice, so remember how I said ratios are just proportion? And what this means is that this 2 out of 5, this proportion, it never changes. So 5 people, there are 2 out of 5 people in the class. 10 people, there's still 2 out of 5 of the total people. Oh, of the maybe, yeah. 2 out of 5 of the total people are girls. Like 5 people, 2 out of 5. 10 people is still 2 out of 5 of them are girls. 35 is still 2 out of 5 people. 2 out of 5 of the 35 people are girls. So all you got to do now. So I think you also learn this in school, like middle school, right? Or yeah, I don't know if you guys have middle school, but I do in curriculum. 2 out of 5 of 35 are girls, and this off here, what I learned in school, I think you guys also learned this, indicates multiplication. And then, so it's as simple as doing 2 out of 5, 2/5 times 35, and then you can simplify this, cancel this out. So 35 divided by 5 is 7. So 2 times 7 is equal to 14 girls. And that's the answer. So the key to this method is actually to imagine that there are only 5 people in the class. So 3 plus 2 is 5. So if the ratio is 4:3, then you imagine there are 7 people in the class. And then you note. Now this is actually the key. You have to notice this proportion. So 2 out of 3, that proportion, the proportion of boys to girls, is actually not that useful. But what this represent, is the proportion of girls to total people. This is the important, because when you figure out this proportion, so remember how we previously said the previous statement here. Yeah. Given a direct proportion, yeah, so we figure it out 2 to 5. And the value of one quantity. Do we know the value of one quantity? Yes, we know the total people is 35. 35 is one of the quantities. Then we can figure out the other quantity, the gross. So this is why we can do this. 2 over 5 times 35 is just 14. And yes, that is this method. Any questions here about this method? Nope. Okay, good. Yeah, so it is 11 right now. So